Hello. In this episode, we're going to be looking at using test mediators for unit testing. Test mediators stand in or mediate between your test methods and any dependencies that you may have in order to try and test something else that you're trying to test here, and I'll explain what that means. They kind of stand in for mocking, as in test mediators and mocking do the same thing, as in they have the same reasons for existence. They just have a very different way of getting there. There are certain issues I have with mocking or the use of mocks, as a result of which I have introduced this concept of test mediators. So in this episode, we're going to be looking at using test mediators to do our unit testing, and I'm going to paint a scenario here that you see on the screen. There's two scenarios. This is the first one, and then we're going to be looking at some code to see how this all plays out. So we have a test method, and we have this code here, in this case the domain facade, that has a place order unit of work that we want to test. So this is an acceptance test, which means we are essentially starting from the point of entry into our system and doing an entire sort of system test. An acceptance test is a test that's sort of a business functionality test to ensure that the system is behaving correctly as per the business requirements of business functionality. The domain facade has a dependency on the order manager. These arrows are showing a dependency, meaning the unit test method here is aware of the domain facade. Of course, this is testing the domain facade here. And the unit test method has a dependency on the test mediator. In this case, dependency is more like it has a reference of or knows of these two classes. The domain facade has a dependency on the order manager. The order manager in turn has a dependency on an emailer base. In the production system, we issue an emailer instance to the order manager. And in our unit testing scenario, we're going to be providing an email spy instance to the order manager instead of the production class. The email spy class is only available in the unit testing project. In other words, it's not a part of the production system or production code base. It's only a part of the unit testing code base. The email spy in turn has a dependency on the test mediator. So if you were to kind of ignore all of this portion here, you realize all that's really happening is that the test mediator is mediating between the test methods and any other classes, in this case our email spy. Okay. And the acceptance test that we are attempting to test here to verify that the system is behaving as expected is, and all this is quite contrived, but so just bear with me. It's a simple system. I'm keeping it simple so that I can actually have a conversation about it over a video. The business says that when an order is placed with a supported product, meaning we sell this product, then besides creating an order record and all the other things that need to happen, also verify that an order confirmation email was sent to the customer. So there's two things to sort of verify. And so what we're going to do is, of course, because this these email classes are so far removed from the class under test, how do we test that scenario? How do we know that in this case an email was sent? If it was verify that the order was created, we have different ways to do that, because we can actually, let's say, query the database to ensure that the order was actually created. In this case, we get an order number back, and so we know that if we get an order number back, the order actually succeeded. But how do we confirm that an email was sent? We obviously don't want to check our inboxes to see that. It has to be automated. And that's where you would use mocking to mock out the emailer and have a mock class in your test methods that allows you to hook into a certain method and stuff. So as I said, test mediators provide you with the end is the same. The purpose that they're trying to achieve, or the problem they're trying to solve, that is test mediators and mocking, is the same. The difference is in the way you get the means to the end. So let's go switch over to some code and take a look at this. All right, so here we have the order manager class, and the order manager class has a few dependencies. We'll be looking at the warehouse service gateway dependency in the next test method that we write in this episode. For now, we're looking at the emailer class that has a dependency. It has a dependency on the data facade that does all of the database kinds of things. And we are essentially unit testing this method here. So let me just show you what this method is doing at a high level. The step one is to validate the incoming information, incoming data. This method will throw an exception if there's something wrong with the incoming data. Of course, at this current time, it doesn't really do anything, but I've got the sort of orchestration there. So you can see that step one is to do the validation. Step two is to call into the warehouse service gateway. This is a remote service. Again, it's not really a remote service, but that's what it's trying to do here. And if the remote service likes the order we're placing, it'll be okay. But if it doesn't like it, in the case where the product is not supported, it's going to throw an exception. If it doesn't like anything, it's going to throw an exception. All of these methods throw exceptions if something goes wrong, so we don't have to worry about did it succeed. If it comes to this line of code here, we can assume that everything before it succeeded. It's called programming to exception, and that's what you're seeing here. It's completely orthogonal to the topic of this discussion, which is using test mediators for testing. But I thought it's important to call that out here. If the warehouse service succeeds and doesn't throw any exceptions, then we come to the next line here, wherein we create the actual order record in our database. And if that succeeds, we get this order number back. Next step is then send this email confirmation, or sort of order confirmation email to the customer. And finally, we return the order number. So this is the unit of work. Both our test methods, both scenarios we're going to be testing today, are going to use this place order method or unit of work to do the testing. Switching over to the unit test class here, I'm going to create a new method, test method. And as I said, this is an acceptance test, as you can see up there. And the naming convention I follow is a naming convention I learned from Roy Osherov. If you want, you can get his book. It's called The Art of Unit Testing. I really like the naming convention here, because it really clears up your intent of what it is you're trying to do. And so domain, that's the class name. First part or component of the naming is the class name. The second is the unit of work, in this case the method name of that class. The third is the scenario. So what's the scenario? Scenario is when order placed with supported product. Then the last part is the expectation. So the expectation is should place order. So this is the happy part, that everything succeeds here. And after that, I like to actually work on the asserts. So the asserts is, as in, given this scenario and expectation, how do I intend to do the assert? So of course the assert would be, first would be, I would like to assert that the order number, that a order number came back, as in it's not null. So I could do, since we don't know the class things here, I'm going to actually define the act here first. So order number is equal to domain facade under test dot place order. The domain facade under test class here, or instance, is the real domain facade. Is I call it under test so that that's very clear in my test methods. What is it that I'm testing? This domain facade is not faked or mocked or anything here. It's the actual class. So order quantity of 1, product name, we'll give it something, and the first is the customer ID, then the product name, and then the quantity of 1. For the product name, we'll have a mind of its own, This is a book I recently read. It's a fantastic book if you're interested in that sort of thing. It talks about how the human mind has a mind of its own. Pretty eye-opening. If you thought you were thinking for yourself, think again. Anyway, so we have this act, the method that we intend to test here. And now I can assert. I can say assert is not no order number. That's the first one. That's the simple case. The second case is we want to ensure that that email confirmation, order confirmation email, was sent. So going back to the diagram here, what I'm going to try and do, or what I would like to do, is to hook into this sort of execution path here, swap out the email spy, or the emailer for the email spy, and in the emailer spy I would like to hook into the method that's going to be called, and let's say increment a counter in the test mediator to say, X email was sent, and every time this method is called, the counter gets incremented here, and then in my test methods I can assert on that. So how's that going to work? So of course we first need a test mediator, which I already have, and you can see that here. So the test mediator has no properties defined for it as yet. So let's define a property in here, and this is a static class, so the property also will be static, and it's going to be called place order. You see I'm going to be extremely specific in the name here. So place order confirmation emails sent count. This is a static property. So you can see the verbose property is intentional, because you want to make sure that these property names are extremely specific. So, and the aim is not to reuse the property or whatever we define in the test method. The aim is to have this one property used only for this one purpose ever. And you don't want to, I've already got a property with an integer that says something like email, so let me just reuse it for something else. And that's why the name is extremely specific. So place order is the unit of work, or the time at which you would use this property, and then order confirmation emails sent count. You may have other emails that are being sent or something, you don't want to reuse this property for that. And each time you define a property in the reset method, you want to always reset it. If it's an integer, you want to set it to a 0. If it's an enum, you want to set it to the first element. If it's a reference type property, null it out. Right, so that's that. Going back to the test method, then I can assert here that in this case r equal 1, which is the number of emails that you expected, and place order confirmation email send count. So we want to assert that this property here has a value of 1. There's nothing to arrange in this method here. Now before we actually swap out the emailer for the emailer spy, I'm going to run this test, because I'm going to just comment out this assert here. So this is using the production classes. There's no test mediator really in play, and there's no spies in play. It's the real classes, the real production classes, and the real production classes write out to the debug console as they're called. Let me show you the code for that. So if I go into the real classes here, you'll see under, let's say, infrastructure services, you'll see the emailer. The emailer has, in the send email core method, it's essentially writing out to the console. And we'll see this part. I'll demonstrate what this looks like. And similarly, for the gateway, warehouse gateway, you'll see that it also writes out to the console in this remove method here. You saw in the order manager, it calls the remove method on the warehouse service gateway. So if I were to run this test here, you'll see that Let me pin this up here. As I said, it writes the output, so I can see this in the output window here. And what we're seeing here is the output that was produced with that test run. Now, of course, when you're doing unit testing, you don't want to be having to look at this debug window to see if stuff worked, and that's the point. So at this point, we've done nothing really towards the unit testing part, but I just want to show you this. So you can see by running that one placeholder method on the domain facade, in turn, the warehouse service gateway's remove method was called with these parameter values. Next, the order data manager's create order record method was called with these parameters and their values. And finally, the emailer's send email method was called with these parameters and their values. So obviously, when we swap out the emailer for the spy, this part will stop happening, and we'll be able to hook into the process chain here. Okay. So nonetheless, there's nothing to assert here. Nothing to arrange. All you have to do is do the assert. Now, if I did this assert like this test will fail because we haven't yet hooked into the email spy or that emailer chain of method calls and replaced it with the spy and then got the spy to increment this property value. So let's see this test fail just so we can see what it means or what's going to happen. So as you can see here, the test failed, and we are seeing that it says expected 1 and actual 0. This brings me to this other aspect of writing. Whenever you use the assert methods, especially is true, is false, and are equal, and pretty much every other method, always write the message. Each of them have an option here to include a message as to why that test would have failed. And the reason is that at this moment in time, when this test fails, we can very easily comprehend or understand why this method has failed, this test method has failed. A week from now, a month from now, a year from now, you won't know why that happened. Or the one of your teammates that comes in and they see this test failing, they see expected 1, actual 0. There's no real clue as to what is expected 1, why is it 1, what is 0. And so you want to make sure you write proper messages here to help with that. So let's say over here we would say expected exactly 1 email confirmation email, but X emails were sent. So now if you run this test and look at the test message again, you'll see it's got a slightly different and more helpful message. So it still says expected 1, actual 0, but then it says expected exactly 1 email confirmation email, but 0 emails were sent. So now this is a lot clearer for anyone that comes in a year from now. You can understand this. Always use the messages, the third or second parameter, as it depends on, as the case may be, to help you with this stuff. In the case of assert is true and is false, try and avoid using those methods. In other words, don't try and coerce something that is not a bool, naturally a bool or boolean, into a bool so that you can use the is true and is false. For example, assert dot is true, something dot count equals 3. That's a coercion into a bool, meaning the actual thing you're trying to test is a count which is an integer. You should be saying assert or equal 3 comma so and so dot count instead of assert is true, so and so dot count equals 3. That's what I mean by coercion. Unless it's naturally boolean, don't use is true and is false. And nonetheless, try and avoid them anyways. In this episode, we'll actually be using the is true, and I'll show you what you need to do in addition to that. All right. So the test is failing, we know, because we haven't yet hooked into the process flow and replaced the emailer with our emailer spy, whereby we can increment this count each time that the email method has been called. So let's do that. So I have an email spy here under the test doubles folder, as you can see. The test doubles folder has another folder called Spies. And this is where under the test doubles folder, you'll have the various other test doubles, such as fakes and stubs. And in the Spies folder and each of the other subfolders that might be there, like the fakes and the stubs, we have this folder hierarchy here. This folder hierarchy mimics the folder hierarchy of your main production system. So in this case, this guy here. So this managers folder is synced with this. In this case, because it says managers, if it was saying exceptions, then we'd find exceptions folder here as well. And under this managers folder here, we have gateways. So if I expand this out, you're also going to see gateways. Under gateways, we have warehouse service gateway. And so you see a warehouse service gateway spy if we had a spy for that class. Similarly, under managers, we have infrastructure services, and then we have the emailer class in there. So we have infrastructure services here, and then we have the emailer spy class here. In other words, if I know I have a spy for this class, I know exactly where to go look for it. And now, in this emailer class, what we want to do is hook into this method here and increment the count on the test mediator. So we do that ++. And that takes care of this aspect where the emailer spy, if its send email method were called, it would simply just increment the count on the test mediator's property, that specific property. Now you could have properties on the test mediator to look at, was the email sent to the right person, did it have the right subject, and so on, by simply adding more properties here, if that's what you wanted to do. Of course, maybe not in an acceptance test, but in another test, you could be doing that in a unit test. So now we still have to replace the, going back to the diagram, let me show you what we've done so far. We've written the test that uses the test mediator's property to ensure that the test mediator's property has been incremented to 1, exactly 1. It can't be 2, it can't be 3, it has to be exactly 1. And in the emailer spy, we've used the test mediator and incremented the property value whenever the send email method on this class has been called. What we've not done yet is we haven't replaced this emailer spy instead of the emailer in our code base. So let's do that. So if I can actually close this out. In the test class here, I'm going to use this. Now, if you're not familiar with the service locator pattern I use in my other projects, then this may seem a little foreign, but the idea is that it's simple to just swap out one class for another class here. We don't know who's actually using it. We just know it's there. And that's one of the key aspects of these test methods is, and the reason I like to use the test mediator is that in my test methods, there's no, I guess, dependency, no notion of dependencies. And the only additional dependency I have is a test mediator. I don't know who is actually using this test mediator. I don't know how this property gets incremented. I just know it's supposed to. And that way, when I refactor my classes, I add more classes, remove some classes downstream from the class I'm trying to test here, my tests are not breaking because I really don't know who the dependencies are or what these dependencies are and how far downstream they are from the class or unit under test. All right, so we are now ready to run this test. I'm just going to run it, and you'll see this test passes. If we were to debug this test, let me put a breakpoint again in the emailer spy. In here. Okay. And then debug the test this time. And you'll see that it comes and stops here. And we have access to all the other information as well. So as I said earlier, if you wanted to ensure in your test methods that the email is being sent to the right customer, or it had the right subject, or it had the right body or content, so a portion of the body contained, I don't know, product name, this, that, and the other, all that can be verified here like that. Okay, and then you step through and that test passes. So our first scenario, we've successfully implemented, and we have a unit test method for that here that does the work. Let's flip over to our diagram and look at the next scenario. So the next scenario, instead of having an emailer base and friends or descendants here, we'll have a warehouse gateway base and the descendants. Everything else is pretty much the same, because the order manager was the class that has the dependency on both of those, the emailer base as well as the warehouse gateway base. Okay, now this is a gateway, so it's a remote service gateway, and typically for gateways you won't be using a spy. You would have to have a fake, and in my vocabulary it's slightly different, I think, from other people's. There's no real fixed understanding of what a spy is or what a fake is or what a stub is, so I've had to find the best fit for the names that I use in my testing. And so a fake is a 100% substitutable class for the real thing. So it's not a simple thing to produce or create. If this class is, or the service functionality you're using here is fairly extensive, then the fake you have is also fairly extensive, except it's not actually going to the remote service. It's doing it all locally, either in memory or some other means, to give you the same feeling as if you were using the real thing. That's a fake. A spy is a spy, as you saw with the emailer. It's called a spy because it allows you to spy into the method call. In this case, what we want is for the warehouse service. The scenario we're going to test is, and let me paint the scenario for you. When you place an order with an unsupported product, the warehouse gateway will throw an exception. So, and then of course the method here should fail, as in the business says that if anyone tries to place an order for a product that's not supported, that should not happen. We should throw an exception and let them know that something's wrong. Of course, in this case, it's the warehouse gateway that's doing the throwing of exceptions, which is a remote service, if you will. It's not the part of our system here. So how do we hook into the warehouse service gateway and say, hey, please throw an exception so that I can test that scenario over here. That's what we're going to test. So the same thing's going to happen. We're going to have a warehouse gateway spy. We're going to hook into the method here. We're going to use the test mediator, and the test mediator would have been arranged this time with an exception, and we'll see that. And then on the test method side, we can assert that exception was thrown. That's really what the sequence of steps is. And of course, we have to swap out the real gateway class for the spy. This time, we are going to be using the test mediator in the arrange part of the test method, not in the assertion. Meaning we are arranging for an exception to be thrown. And of course, in the assertion, we assert the exception was thrown. So we don't have to use the test mediator over there. Okay, so let's look at how that goes. So create a new test method here. And again, it's got the same naming convention. Let me just copy that. So place order, when order placed with non-supported product, should throw. When I say should throw, I just mean should throw an exception. Should throw. All right. So in this case, we can do the arrange first. In the arrange, actually, we also need a specialized exception. I like to have very specialized exceptions for the business scenarios, meaning if there's a business problem that needs to be highlighted, then there are very specialized business exceptions in the system, and the system will throw those exceptions. So I think I already have that exception. Let me see what that is. So you can see here, yes, it's a product not supported exception. So it's a very specific to the scenario when order placed with non-supported product. And this one says product not supported. In other words, this exception, because of the name and its intent, can only be thrown under this condition, this scenario. So it's a very specialized exception. So here in the test mediators, we'll have test mediator dot. Now the property doesn't exist, so let's go create it. We'll say same thing, place order, and in this case we're saying place order product not supported exception is equal to new product not supported exception. Okay, and here we'll provide a message that says this product is not supported. Need to also define this property here on the test mediator. So let's define that. And now that this property is defined, we also need to make sure that we reset the value of this property. Right? Otherwise it'll not work correctly. So let's do that. In this case, because it's a reference type, we are going to set it to null. So every time you define a new property on this test mediator, be sure to reset that property the way it's supposed to be reset. Okay, so in the arrange, we arrange for the exception. We're saying, okay, whoever it is, please use this exception with that message when you intend to throw an exception. We don't know exactly who it is. The act is going to be exactly the same, so we just copy this here. And in the assert, this assert gets a little tricky. Now, because this is a very specialized exception, you can actually use the expected exception feature we have in the unit testing framework here. So expected exception would be type of product not supported exception. Right? Because this exception is very specific, which means this exception will be thrown by our system only under this one scenario, which is if ever somebody places an order that's not supported, that's the only time this exception will be thrown. And that's important that you use the expected exception message only for those exceptions that are extremely specific. If the exception is not specific, and I'll show you that case, that's very important, then you shouldn't be using this. What I do in that case is I use, in this case, product not supported exception like that. Even though it's very specialized here, I'm showing you the scenario. So all right, so we're back to just being able to get the assert up here. But we're asserting, we're asserting in the catch. So we're doing our assertion over here. Okay. So we are expecting an exception, therefore we place this in the inner try catch. We're only interested in catching this specific kind of exception, which is intentional again, because we don't want to be catching any generalized exception here. And if no exception is thrown, we do want to assert fail this method here. Now here we can say again very clearly we were expecting an exception of type this guy here. Of type the, but no exception was thrown. So it makes it very clear as to why this test failed. Now in the case of the expected path, what we want to do is we know the exception has been thrown, so we know that this specific exception was thrown. We want to assert that the message contained in that exception also has a part or a component of that exception, not exactly the same message. You don't want to tie yourself to the exact same messages just in case you change the message, your test will fail. So what I do is I have a variable called expected message part, and in this case we'll just say the message part should be not supported, like that, and then assert is true. And in this case you'll see why I'm using is true, because I'm using an actual bool. I'm saying e dot message dot contains expected exception message part. And as is usual here with this true, always use a message to indicate why this assertion failed in the case if it did fail. So here we would say an exception was thrown. Of course we're here, so we know an exception was thrown. However, the message was expected to contain blah, so that'll be our expected message part. But the exception message was e.message. So you can see how extremely specific I get here. That's intentional, because remember your unit tests are as good as your failure messages. Having a bunch of unit tests without really clear failure messages is actually a useless effort. You might as well just not write your unit tests, because when things fail, that's when you want the help. And especially if you're not the person who wrote that test or that part of the system, it becomes extremely difficult to understand what went wrong. And so then what was the point? So your aim when you write tests is to ensure that not only for yourself, but for your other team members and anyone else that comes into the team later, years from now, has these exception messages as guiding reasons for why a test has failed. So your tests are as good as your failure messages. Okay, so we've done this and implemented the entire test. We've arranged for the exception to be thrown. we call the method here because we are expecting an exception. If we don't get an exception, we fail the test, giving a real reason or good reason for why that test has failed. If we do get this specific exception here, then we assert that the message contains a portion of the exact message, and the portion has to be something that's reasonable. So not support is kind of like the key part here. So tomorrow, if you do change this exception message for whatever reason, you may have to change this expected message part, but don't try and keep it the same exact message. All right. Now what we've not done is we've not hooked in the two other parts, which is we've not swapped out the warehouse service for the spy, and we've obviously not implemented the spy. So let's go implement. Let's see this test fail so you know how it works. I guess I got a typo somewhere. Oh yeah. Okay, so that test failed, as you can see here, and it's saying we were expecting an exception of type product not supported exception, but no exception was thrown. So that's what we expect right now for it to fail. But that's a good reason for it to fail, and we can see that part. And it's also important to test those scenarios. It's also important to test that your test fails under the scenarios you expect it to fail, because you never know. If you don't ever test that part, you don't know if the test is actually going to work. Now moving on to the gateway service spy. What we do here is we come into this method here, and we just use our test mediator, and we use this exception. So we have access to the exception. So all we need to do is throw this exception. But we want to throw this exception under certain scenarios only. That is, if this property has been set, only then do we want to throw this exception. So if test mediator dot this exception is not null, then throw this exception. And the reason is that, as you know, we use that reset. So for other tests that might call into this remove method on the service gateway, the exception won't be thrown, which is how we expect that to happen. We don't want the exception to be thrown unless we actually set it prior to running the test, right? So we've done that part, and the next step is to replace the gateway, the original gateway, with the spy. And so now we should have this test passing, hopefully. Okay, so the test passes. So let me run them both. So you can see both our tests are passing here. I guess it doesn't see an output here for some reason. So anyway, both scenarios have been tested. Both methods, as you can see here, don't have any reference or knowledge of any of the dependencies. They use the test mediator, so they are dependent upon this test mediator. They are aware of this test mediator, and they know to test certain properties or to arrange certain properties, but they don't know how far removed these classes are, what those classes are, and what methods are being called, and that whole thing. And that's sort of the reason I like to use test mediators instead of mocks. So going back to the diagram, so we've tested these two scenarios in which we're using the test mediator instead of mocks. One of them is hooking into the email spy and incrementing a email sent count property, and in the test method we assert on that count to ensure it's been 1 and it's exactly 1, as not 0, it's not 2. And in the other case, we use a warehouse gateway spy, where in our test method we arrange for an exception that we would like someone downstream to throw, and the warehouse spy, we hook into the warehouse spies method and pick out the test mediator's exception and throw that exception if it's set. So I hope this episode was useful in understanding how to use a test mediator and a spy in conjunction with the spy to test classes or units of work that are dependencies or downstream from the class or unit of work that you are trying to test. And I'll see you next time.